two forces, F1 and F2, of magnitude 60 and 70 pounds respectively, act on an object. The direction of force 1 is north 40 degrees east, and the direction of force 2 is north 40 west. Find the direction angle of the resultant force. Express the direction angle to the nearest tenth of a degree. All right, this is not a simple question. So we have two forces. So let's start with a little axis system. Whenever they give us these directions, north and east and degrees and stuff, it's best to have an axis system. So we'll put the object right here at the center. There's our object. So one of the forces is acting what? North 40. So this is, remember, north, south, east, and west. So it's acting north 40 degrees east. Now, do you remember how that works? That is from right here straight north, but not straight north, 40 to the east, to the right of north. North, but 40 to the east. So there it is. And that one is 60 pounds. So there's force 1, and it's 60 pounds in that direction. The second one is what? It is north, but 40 west. So straight north, but 40 to the west. And that one's going to be a little bit longer. Make that one just a little bit. Here, let me just back this up. Yeah, there we go. Let me back this one up too. Okay. And up too far. Back it up to about there. That was not quite as long. I probably overdid it a little bit there. Here, let me do a little better. About there. Okay. So, and that one, this one is 60, and then the other one is 70. So it's a little longer. So there's the, and this one's also 40 degrees this way. So there's our, this is force vector 2. This other one is force vector 1. Okay, so there's the two force vectors, right? Force 1 is 60, force 2 is 70. Force 1 is north to the east, force 2 is north, but 40 to the west. Now, what's going to be the resultant? This is what they do in physics and engineering. They figure out, you got some forces acting on an object. What's the result of all these forces? So the resultant, can you see it? Imagine if that's a rope pulling 60 pounds of force up to the right, and then another rope pulling up to the left with 70 pounds of force. So the 70 is a little stronger than the 60. So it's gonna, the result is going to be something. Can you picture it? The result's going to be something about like that. Why is it going to the left? Well, because the left pull is a little stronger than the right pull, and they're both pulling up. So it's going to mainly go up north, but a little bit to the left. That's going to be what we call the resultant. It's the result of those two. It's the overall effect or result that's going to be pulling or pushing, either way, moving that object. It's going to be, that object is going to feel pulled in that direction, north and west a little bit, mainly north, but a little bit west. Now, exactly how do we find the specifics and the specific angle? They want the direction angle. So what we have to do is a lot of work here. And so first off, what we have to do is on step 1, we have to change both vectors to I and J. That's going to be a lot of work. So change both vectors to I and J. Let's take the first one. Well, how do we do it? We've got, and that requires the angle from 0 degrees called the direction. Is the same word they're using here, the direction angle. So in other words, we've been given like the 40-degree angle right there, you know. that's not from 0. Here's 0 degrees, right? So what's the angle from 0 degrees? That's what we have to figure out. How far from here to there? Try that again. I thought I had a different color there. How far from here to there? That's from 0. Well, can you tell that must be 90 minus 40. That must be 50 degrees, right? Because it's 90 straight up, and and then this 40 is how far off of 90. So that must be 50 degrees. So that's his direction angle. So force 1 equals, how much is force 1? 60. 60 cosine of 50 degrees I plus 60 sine of 50 degrees J. Let's get some numbers on that. So you have to get the direction angle, the angle from 0, to use that formula. Make sure you're in degree mode. I'm getting 38.567I plus 60 times sine of 50, 45.963 J. Okay, now force 2. Let's go for force 2 here. Force 2. Now what's the direction angle all the way from here all the way to force 2? That's his direction angle. Remember, a direction angle is the angle from 0 degrees. We got to get his direction angle. Well, all the way to here is 90, and then he goes 40 more than that. So he must be 90 plus 40. He must be 130 degrees. His direction angle from 0 must be 130 degrees. So he's going to be 70 cosine of 130 plus 70 I plus 70 sine of 130 J. So take out your calculator. Let's figure those out. I'm getting negative 44.995 I, and then 70 sine 130, I'm getting 53.623 J. Okay, so we changed both vectors to IJ using the direction angles, the angles from 0 degrees, and the general, the magnitude times cosine of the angle I, magnitude sine of the angle J. So now we got force 1 and force 2 vectors. All right, step 2. Add force 1 plus force 2 to get the resultant. So let's add them together. Force 1 plus force 2. So force 1 vector, I'm going to add this number and this number, so the resultant vector will equal, so just use your calculator, so 38.567 minus 44.995, I'm getting negative 6.428I, and then add the two J numbers. That number and that number. 45.963 plus 53.623. And I'm getting 99.586J. So there's the resultant vector. And notice how it's a little bit to the left, right? Negative on the I. The I is the x-axis, the right-left. Right, this is the I-axis, this is the J-axis. It's a little bit left and mainly up. See how that fits with the resultant right here? A little bit left, but mainly up. Perfect, just like we thought. Now, that's step 2. Step 3, the final thing, we got to find that angle. We got to find that, what angle? The angle from here all the way. This is the main thing we've been shooting for all the way along. What is that angle right there to the resultant vector from 0 degrees, right? A direction angle again. The key to this problem is knowing the direction angle is always from 0 degrees. So how do we find that angle? Well, that's where we use inverse tangent as part of the deal. So step 3, find the resultant direction angle, which means from 0 degrees. How do we do it? Well, tangent inverse of the positive j over the positive I. You take the positive versions. This is a little tricky. Math Excel doesn't make this very clear. Make sure you understand what I'm saying here. So take the j, the positive version of it. This is the most important part. A lot of people do good to hear and then mess up the very end. They'll put the negative. Watch out. That's why I'm saying it's got to be positive. This won't be our final answer. Then we'll have to do something else. But first, start with this. Hit tangent inverse. So what this will be is the angle reference. This will be the reference angle that we're going to get. So the reference angle will equal the tangent inverse of that. And I'm getting 86.307 degrees. Now that's the reference angle. That's not the actual answer yet. That's the reference. Now what do we mean reference? Well, look up there at the resultant vector. Where is it? It's in the second quadrant, isn't it? All right, let's draw it down here. This will be helpful. We're almost done, but you can't mess up this last part. So there's an axis system. Remember, our angle is, our resultant is somewhere in the third quadrant, right? Like there's our resultant vector. It's in the, second quadrant. And then what's this reference angle stuff? Well, the reference angle meaning, what does reference mean? From the nearest x-axis. That's what you got to be 100% clear on. A reference angle is the angle from the nearest x-axis. So that means from here to there is 86.307 degrees, isn't it? Okay, so what? Well, I need to find the direction angle. That's what they're asking me for in this question. The direction angle, which means from 0 degrees. So from 0 to the resultant. Here's 0. This is the direction angle. So what's that going to be? Well, now you can see it, can't you? If we went all the way to here, that would be 180, and then we have to back up 86.307. So it's going to be 180, back up, subtract 86.307 degrees. So what is that? Use your calculator. I'm getting 93.69 degrees. 93. So this direction angle must be 93.69 degrees. Look, it makes sense. It's more than 90, isn't it? So that's the actual direction angle. So you see how we found this in the end? This is, and let's go see. Is that answer there? 90, yeah, there it is, B, 93.7. We got it. So you see the trick, right? This is the part most people stumble on. They'll do good all the way to here. They'll get this resultant vector, but they don't know how to get the angle. How do you do it? You take the tangent inverse of the positive j over I, because tangent is sine over cosine, so sine is up and down. It's y, it's j. J is up and down. I is sideways like cosine like x. So, but the positive of both those, get your angle, and then know that's a reference angle. It refers to the nearest x-axis. So put your reference angle, draw your vector. You've got to draw your vector. See how I drew the resultant vector, because you got to see which quadrant it's in. So you can't skip that. That's the step most people skip. Draw the vector to find the quadrant you're in. You can't skip that step. So I drew it. It's in the second quadrant right here. And so then I knew the reference angle from the nearest x-axis was right there. Then I could find the overall direction angle from 0 by going 180, back up, 86.3, subtract. Got it. There we go.